because it's difficult for me. I'm in Patna, and it's getting slightly difficult for me to look into the arrangement and also the availability of net connectivity. It's intermittent over here. In the short notice, I was at Patna, so I had to adhere
Yes.
to the schedule that I do based on highway. But today, I need to be slightly willy-nilly on timing. So you'll have to today excuse me for whatever you are facing.
Yes, it's just 1 minute. Let me just prepare.
Because I'll
Let me
not
have
be
a
even with report with my arrangement. Well, please do the needful.
Yes, sir. I'm doing started the recording, sir.
It's very important, and I will not be repeating this class. This class is generally not taken, and it is on gravitation. General gravitation per se is not taken in totality, let alone what we are going to take today.
Yes, sir, I'm here.
Okay. Shall we get into detailing?
Yes.
Okay, Bibha, did you start the recording?
Yes, sir. I started the recording.
Okay. Before of getting into the nitty-gritty of what I want to take today, I wish ask, are both of you aware of latus rectum? What is latus rectum?
Yes, sir.
Do we know what is eccentricity, Bibha?
Sir.
Do we know what is eccentricity?
No, sir. I'm not aware of it. I'm trying to recall, but I'm not aware of it. I'm trying to recall, sir.
What is it? Recollect.
Sir, I don't know, sir. Sir.
So you're not aware of latus rectum, you're not aware of eccentricity, correct?
So latus rectum. I'm aware of it in
What is it? What is it?
Is the sir.
Stop stuttering, Bibha.
Sir, I'm
One
unable to put it into
One
words,
who
sir.
discombobulate. You know the meaning of discombobulation? Frothing in your mouth. One who is to discombobating, they are generally not sure of what they are speaking or what they will be speaking. And that's the reason you start stuttering. Are you aware of directrix?
Sir, I'm a bit dusty on the topic, sir. I have to go through the topic, sir.
That's the reason I asked you to go. Do you know that there is a line and there is a point? The line is called directrix, let's say, and a point is called focus. Eccentricity is what to us? Eccentricity is the ratio of the two distances, any point you take. Ratio of distance of a point from focus to directrix. I repeat, the ratio of distance of a point from focus, please write it down. Ratio of distance of a point from focus to a line. The line which I'm into referring is what is called directrix. The line which is what I'm into referring is what is called directrix. So if I am to show, I will take a point P, I'll take a point which I'll mark as focus, and then that point distance will be measured I'll show it to you what I mean by it. This is theta. I'll show it to you, and you'll get to know what I mean by directrix. Please take a look. Can you check it?
Sir, I'm in it.
So you're not on video.
Can
Sir,
you
I'm
check it?
Sir,
No,
I'm
sir.
on it.
Is it visible to you? It
No.
should be visible. Check. If not visible, there is some problem in your connectivity. Is it visible, Vasdev?
No, sir, it isn't.
Sir, it isn't.
Is it?
No, sir.
No, sir.
Not visible
Unless
then?
he's a. No, sir, not visible.
Nothing is visible, is it?
No, sir. No, sir. I'm
No,
just
sir,
able
you
to see.
do not seem to have your video on.
Video isn't on. The back
Yes,
camera
that's what it
is
looks like.
on. The back camera is not visible, it seems. Okay, fine. I'll take the front camera then. Is it visible now?
Yes, sir, we do see a sheet of paper.
Yes, sir.
You see that? There's a sheet of paper or the line?
Yes,
The
sir.
line is being shown. The line is being shown, and the
Can you
angle, some
Can you
angle.
see
Yes,
this S? Can you see this S? This point being marked S?
Yes, sir, we
yes,
do.
sir.
This is focus. And this line this is directrix. Not visible?
Sir. Yes, sir. It is visible, sir. It is visible, sir.
It is visible, sir.
And the ratio, which is what I'm referring to, will be R, that is the distance of this point P from S to distance of this point P from this line. Area,
Yes, sir.
what will be this distance? What will be this distance? This one plus R cos theta, agreement?
Yes, sir.
So this one we mark as S, let us say, this total we mark as, or whatever you want. There will be what to us? It will be S plus R cos theta. Is it okay?
Yes, sir.
Yes, sir.
This is one point which I want to highlight before I get into the discussion on gravitation. This is something which I am drawing from coordinate, I would say conic section. Coordinate geometry fine, but specifically conic section. In conic section, we do find ratio of a point from another point. The other point is called focus. 2 of that point from a line. And that ratio is what is marked as E. That is what I have shown over here. E is equal to R, that is distance of this point from focus, divided by distance of this point P from the line, which is having the nomenclature of directrix, which is what being mentioned over here, R divided by S plus R cos theta. Clear, dear?
Yes, sir.
Okay. Now there are two angles which I will read this for. One angle is 0 and the other angle is 180. I'm reading this equation for two angles. I repeat, one angle is 0 and the other angle is 180. Fine?
Yes, sir.
Lydia,
Yes,
can I
sir.
get this equation in terms of, in fact, I'll do it for you. ES plus ER cos theta is equal to R. Is it visible?
Could you be a bit more generous with the size of your handwriting?
Sure, dear. ES plus ER cos theta is equal to R. Am I now
Yes, sir.
legible?
Yes, sir.
Okay. I take R to one side, terms having R to one side. ES is equal to R minus ER cos theta. Find here.
Yes, sir.
So ES divided by, what shall we write? What is the term that I'm getting over here? If I take R out, what I'm left with? 1 minus E cos theta. Agreement here?
Yes, sir.
So, what I wanted to make subject is R. What is R? ES divided by 1 minus E cos theta. Correct, dear?
Yes, sir.
This is what we refer as latus rectum. What is latus rectum? E into S is what is being abbreviated as L. So L by R is equal to 1 minus E cos theta, where what is L called? I repeat it. 1 minus E cos theta is equal to what to us? L by R. Visible?
Yes, sir.
Okay. What is L over here, dear? Vasudev?
Lattice rectum.
Yeah. To be precise, semilatus rectum, correct?
Hmm.
Okay, and what is it basically? Product of E and S, where S is what? You know. E is eccentricity. You're aware of all now, correct?
Yes, sir.
Let me take two angles which I did profess. One is 0, the other 180. So if I take 180, what I get, L by R is equal to 1 plus E, correct?
Yes, sir. So would it be possible for you to change the orientation of your camera? We're having to read everything sideways.
Sure, sure. I don't know why the back camera is not working. I thought it should work. Is it fine? Check once.
So it's upside down.
It's upside down.
Down. Okay.
Now we can't see anything at all.
Nothing visible?
Now it's a bit
Yes,
blurry, sir.
it's out of focus.
It's blurry.
Getting out of focus. Just wait a minute. I'll make the back camera visible and convenient for all of us. Any luck?
It's still blurry.
No, it's out of coming on focus and going out of focus. Okay.
Okay, yes. Bear with me. Yeah. Now, any luck? No.
It's certainly readable. Yes, I think we can make do with this.
Okay, I'll be able to make. I was last time clueless what I'm showing, where I'm showing. I'm able to make this back camera operational. If you can allow me this liberty. Is it
Yes.
manageable?
It's manageable, sir. It is so.
L by R is 1 plus E cos theta. I wrote for theta 180, right?
Yes, sir.
The other can be L by R is equal to 1 minus E for theta 0 degree, correct?
Yes, sir.
If we add them, what do we get? Twice of L by R is equal to 1 minus E square, right?
So E squared.
Oh, sorry, 1 plus E, 1 minus, not multiply them rather, not add them. If you multiply them, then we
Yes,
get
sir.
L square by R square. And I could make a correction over here. L square by R square is equal to 1 minus E square, correct?
Yes, sir.
Yes, sir.
So this is an equation which I keep aside. We'll be using it. When and where you'll get to know now. Now to the moot, please. What I'm trying to establish over here, is centricity relation with energy. And from there, we will solve for the exact conic sections. We will not take circle. You will learn in soup if it's asked that it is not a circular track. How can you prove energy, or for that matter, whatever you are to, be it orbital velocity, time period, how do you relate to circle? All relations that we have studied are vis-a-vis taking slight liberty, I would say, on the orbit. They are never circular, though we have proved only for circular orbit. Do you subscribe to what I'm suggesting?
Yes, sir.
You will not be able to, with whatever you have studied, in any way reach the conclusion, same conclusion, if it's being asked that you are not supposed to take circle. All will fall like house of cards, nothing, all 9 pins. You will not be able to justify. But that justification is what I seek, and this justification which I'm into is a pet question when it comes to Olympiad examination. It's a pet question. Let me make it amply clear over here. It may be beyond mains, but can very well be a part of advanced. Certainly is much to lay credence when it comes to Olympiad examination. Clear? So I had today, and I could have indulged, otherwise it'll be difficult for me. I wanted to, I was supposed to take, I told you earlier also, I have told you that I am to suppose, but just to suppose which way is to be supposed, that was to be taken. Today I had few minutes with me as I'm off station. So I thought of indulging instead of not utilizing this time. Right? Excuse for the bearance that I am letting you to. Okay, dear?
Yes, sir.
Shall we proceed?
Yes, sir.
Any point in time is not legible, please make me aware of this. Okay? Can we write energy of a particle? I'm showing a particle first. There is a particle, and this particle is somewhere over here at a distance r. Okay? I want to write x coordinate of this particle. You're aware of how to write. X is equal to what to us? R cos theta, right, dear?
Yes, sir.
Which gets me dx by dt as dr by dt, as r can vary, cos theta, this is a product rule, you are aware of it, plus r into differentiation, so minus of sine theta into d theta by dt, right?
Yes, sir.
Similarly, dy by dt, why you know what can be marked over here with this depiction is r sine of the angle theta. So what do we get dy by dt, dear? R into cos theta, d theta by dt, plus dr by dt into sine theta. Correct? Why do we seek dx by dt, dy by dt? Because I seek Vx and Vy. Why do I seek Vx and Vy? I want to write energy of this particle. Energy of this particle can be marked in kinetic terms as half m Vx square Vy square. Correct, dear?
Yes, sir.
Vx square plus Vy square. What do we get when we square them? You can let me know. Vx square plus Vy square. I seek Vx square plus Vy square. What will we end up getting? It's pretty obvious. I seek Vx square plus Vy square.
So you get dr by dt whole squared.
We get dr by dt whole square. Agreement. What else?
So you also get r d theta by dt whole squared.
Okay, so plus r d theta by dt whole square. Anything else that we'll be getting?
So I think the other term cancels out again.
Cancel. Similarly, can be seen if it have taken v this way, then breaking it into two components, you would have got the same. Okay, you would have written the tangential component as r d theta, and this component as dr by dt. Correct. You would have gotten
Yes.
straight. Fine. So this is energy. This energy is kinetic. So this what we will add here. I want the energy equation which I seek is in totality, in its entirety, and finality. So what we need to do over here, we'll be adding the potential part, correct?
Yes.
Minus of G, capital M, small m, I, R. I am coming from what being in our known energy front. This particle is at distance R. So this is a potential energy. They add up to total energy, right there?
Yes.
So this is the total energy which I'm getting. This is energy which we seek, but there is no relation as such established between this energy and what we seek, a relation, eccentricity, which is related to dielectrics and focus. Could you lead me? What shall I do thereafter? Because I have to factor in something. I have to rope in what we have studied about E. I have to rope in that factor. So could you be some help on this? How should I go about it? I get you few data. Maybe you will be throwing some light and getting some enlightenment. I get you few data, and what are they? We are aware of that angular momentum will remain conserved. Subscription?
Yes.
What is the angular momentum for this particle? I into omega, mr square, d theta by dt. Correct, dear?
Yes.
It will be constant. I write k for it. Okay, constant. What else we get is r square d theta by dt from here is equal to k by m, and k by m is another constant h, as m is also constant. Correct?
Yes.
Okay. Could you please help me rewrite this equation? Now half m I keep as it is. Fine. Bracket open. I seek r d theta by dt. There's a replacement which you can get me over here. This is r square d theta by dt whole square, correct? Can we write in terms of h and r? What will it be?
Yes, it will be h d theta by dt.
Yeah, d theta by dt I don't want. Yeah, h and r, this factor in terms of h and r. Can we replace for d theta by dt whole square is what I seek. H will remain, and what will you get in the denominator? Tell me, I want a replacement for this one. Not visible?
One second.
Okay. Just replacement for d theta by dt whole square, nothing much.
It's h squared by r squared.
So h squared by r squared we get over here, right?
Yes.
dr by dt whole square, we keep as it is, dr by dt whole square. Minus
So
of g capital M small m by r. Right?
So I think
is
you missed the
equal to E.
superscript on H.
Yes, dear.
H squared.
H square. Right?
Yes.
Do check. All good?
Yes.
Tell me, what next shall we be looking forward for? What shall we do? Because what I'm trying to incorporate, they are all there up for you. R squared d theta by dt has been already incorporated, right?
Yes, sir.
Now, there are few terms mathematically which we'll be introducing, but take a good look of what all being done as yet. Anything to be asked? I didn't do much. I just tried to represent it in the form of energy, and in energy equation we have used I into omega, right?
Yes, sir. So basically, we got a differential equation in terms of R, which we can solve for
Can you
a
help?
trajectory.
Can you help me get differential equation, dear?
So that is a
Can you help
differential
me
equation.
further on this differential equation? Okay, let me ask you categorically what I seek. Can I get dr by dt from here?
Yes,
Will you
you
help
can.
me on dr by dt? Nothing much. Just make dr by dt subject, and I'll let you know why I want dr by dt to be made subject. In fact, if you are spunk enough, you will be able to understand that entire of my razzmatazz is based on how can I relate r with theta. That is what I seek. I am already having d theta by dt, correct?
Yes,
d theta by dt is, as you can see from here, h by r square, correct?
yes, sir.
If I get dr by dt from here, then I will divide dr by dt with which term? D theta by dt to get dr by d theta,
D
correct,
theta.
dear?
Yes, sir.
So my aim is to get dr by d theta. I'm using the equation mark 2 and equation mark 3. Equation mark 3 will get me dr by dt. Please do help. What will dr by dt tantamount to?
So it will be E plus GMM by R.
And 2 will also go up there.
Yeah, times 2 by M.
Okay, and
Minus
h
H
by
squared by
r
R.
squared. Okay. So we can write it down. You write it down. Check what you're getting. Check what we get and accordingly we'll do. If you can get me dr by dt, fine. If dr by dt only you do. Dr by d theta I'll get. Dr by dt or dr by d theta.
So once we get dr by d theta,
Yes.
we can integrate on both sides to get the trajectory in polar coordinates.
Exactly. 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 Yeah, few manipulations, mathematical manipulations will have to imply. They will be deployed as and when falls need. But to formulate it, we require dr by d theta. That formulation I'm looking forward for. What is dr by d theta? Shall we? Shall I take this space to get this? Is oh fine. We check this first. Yes, Vibha, what did you get dr by d theta as?
Sir, I'm still trying to solve it, sir.
What is there to try this hard to solve, Vibha? E plus G capital M small m by R. First you would have written this. And then what you got to do? This term we multiplied with it. So into, this should have been taken into 2 by M. Okay, right? And minus of H square by R square whole under the root. This would have been the case. Please do check. Nothing much. I
Oh,
didn't
I
do a thing.
Camera's out of focus again.
simplified it in another way. I simplified it another way. That's why I got it.
Okay. Not able to see out of focus, right?
Sir, leave.
Better now.
So that's tilted again. Yes, sir. That's
Better now.
yes. Sir.
Okay. So this is dr by dt, right, dear?
Yes, sir.
Shall we write now by dividing? Now we know what is, I write over here. We know what is d theta by dt. D theta by dt is what to us? D theta by dt is what to us? D
H
theta
by
by
R.
dt. Yeah. The d theta by dt is h by r square, as you said rightly so, Vasudev, h by r square, right? Visible?
Yes, sir. It is.
Then can you help me with dr by, right, can you help me with dr by d theta?
Yes.
Dividing them. Dr by d theta.
Yes, sir, but you do get a result that doesn't seem pretty straightforward to integrate.
In that case, I'll write it down if it is getting difficult to fathom dr by d theta here. Not issue. To get from what be dr by d theta is visible camera. Is visible the shot which I'm letting videotaped. No?
Yes, like not now. I mean, it keeps drifting in and out of focus. So.
Yeah, there's no problem with this network as well over here. After all, I'm in Bihar, but now I think it's clear now.
Yes, sure.
So dr by d theta is what to us? I get
Yes, sir.
Yes.
So
1 by h. Endorse me if I'm getting it right or not. Please do check.
yes, sir.
1 by h. 2e by m. We have r as well, right?
Yes, so shouldn't it be r squared by h, or have you taken the r inside?
I've taken the r inside.
Yes.
Plus 2g capital M r cube.
By h squared, yes. Sir. So okay,
Okay.
h outside, h outside.
By what will it be? Minus of h square r square. Just check once.
Yes, sir.
minus of h square r square. Right?
Yes, sir.
Okay, I write now the eventual one. So I take the variable separation method, dr divided by 2e mh square r raised to the power 4 plus 2gm h square, right?
Yes, sir.
R square, right? Or r cube? No, r cube, right? R cube, right?
Yes, sir.
Minus r square whole under the root is equal to d theta. Please do check. We are eventuating now.
Yes, but how do you integrate this behemoth?
I'll tell you. Yeah, exactly. That's the reason being taken. Yeah, that's the reason being taken. That par for the course. How do we integrate it? What to do? What form we can bring it in? And how can we? Simple. Replace it by u. R is replaced by 1 by u, let's say. So dr is what to us? dr is what to us? Minus of du by u square. Agreed?
Yes, sir.
What do we then get? Minus of du by u square and the term which I am having. The term, I'll rewrite the term just to be more in abreast to it. Square, taking u now, u square plus 2gm by h square, correct?
Yes, sir.
U cube minus 1 by u square is under the root is equal to d theta. Do check.
So isn't it u to the power 4, 1 by u to the power 4, 2e mh square, 1 by u to the power
1
4?
by u to the power 4. Absolutely correct, yeah. You're right.
Yes, everything else is right.
Now you can get me some inkling, Vasudev. Can you walk me through? What shall I be doing next?
Yes, I have not exactly dealt with such integrals.
Shall we take u square inside? Make it some clue,
Okay.
some hunch. You can play now your hunch. You can play
Yes.
now your hunch. Come on, Vasudev, speak up.
Yes, so you do take it inside, and I think you get a simple polynomial. And
Yes. That be 2e. I'm taking u square inside, right? So this will go, correct?
yes, sir.
mh square plus 2gm, right?
u, so 2gmu by h. Yeah.
Square, yeah, u, there'll be a term, right? And minus of
Yes.
u square, right?
Yes, sir.
I've taken this u square inside u4, so u square left, right?
Yes, sir. So
Easy.
usually, I think
Now
you can use
what?
some inverse trigonometry here.
Yeah, we will be using, but first we'll have to bring it in that form, a square minus x square form, right? Which we have gotten, I
Yes.
presume. We have to convert it into a perfect square now, right? Correct?
Yes, sir.
So I get the end result in a way if you can bring it to this form, d zeta divided by under root of a square minus zeta square is equal to d theta you will be getting, where zeta will be what to us? Zeta will be u minus gm by h square. And what else? A, right? A will be what to us? You have to just convert it into a perfect square.
Yes, sir.
E by mh square plus G square M square by H square. Please do read here.
Yes, sir.
This will be A. And careful with the solution. Solution of this is cos inverse zeta by A is equal to theta minus alpha. Please don't write theta, you will be wrong. Theta minus alpha. If you take the reference as theta equal to 0, only then you can go ahead with theta.
Sir, isn't it sine inverse?
A square minus zeta squared here, d theta. Sine inverse is x square minus a square. No? You can take sine inverse, that will get you the same dear.
That's the way of sir.
dx by a square minus x square, you can take it as sine, no issue. Sine inverse x by a.
Yes, sir.
Sine inverse x by a. Or you can say cos inverse zeta by a, but with this function, theta minus alpha. You want to take
Yes.
sine, you can take sine, no issue. That is fine. It should be understandable. After all,
What's
change
alpha?
alpha. See, if you alpha is a constant of integration, yeah.
Oh, okay. Yes.
Right. So if I measure theta not from 0 Vasudev, but theta from alpha, are you getting it?
Yes, sir.
If I measure theta not from where? 0, but theta from alpha, that means I'm taking alpha as reference. Then what do we get the final equation as? Zeta by A is equal to theta, right?
Yes, sir.
Then zeta is equal to what to us? A cos theta. And what was zeta? I told you this is zeta, right?
Yes.
So u minus gm by h squared is what to us? A cos theta, right?
Yes, sir.
Okay. Now tell me what do we have? U minus gm by h square is what we wrote is equal to what? A cos theta, right?
Yes, sir.
Any further now? What shall we be doing?
So could you turn back to the previous page?
Yes, sure.
Just a second. It's out of focus.
Better.
So now it's just a blob of red.
Let me try. Now, dear.
Yes, sir. Yes, sir. Read.
Shall we?
Yes, sir.
Okay. Can we remove now u for 1 by r? That was the
Yes, sir.
replacement. So 1 by r is what to us? Tell me. What are you getting is 1 by r minus gm by h square, right?
Yes, sir.
Is equal to a cos theta, correct?
Yes, sir.
Rewriting it, h square by gm by r is equal to 1 plus ah square gm cos theta. Check here. Nothing much. Just manipulating with equation. I wanted 1 there. 1 plus to make it even with the equation which I am eyeing. Can you check it, please?
Yes, sir. It's in front.
Did you get the form which we were looking forward for? L by R is equal to 1 plus E cos theta.
Yes, sir.
L by R. This is L R is equal to 1 plus E cos theta, right, dear?
Yes, sir.
So write the final equation now, H square by GM divided by R is equal to 1 plus, now I write the value of A, 2E H square G square M cos theta under the root. Just
Yes.
replacing, just substituting for A, nothing much. You're aware of what is A, what did we take A, correct?
Yes, sir.
And this will be related to the lattice semilattice rectum equation. L by R is equal to 1 plus E cos theta. So what is E here? E is 1 plus 2 capital E H square G square M square small m under of the.
So what is capital E again?
Energy.
Ah,
If energy is 0, small e will be 1. If energy is 0, small e will be 1. What shape you will get for E equal to 1?
parabola.
Yes. So for parabolic part to be followed, energy total of the particle should be 0. Let us now take Earth and Sun.
So what about a circle? You'd have to get E is equal to 0 for that. I don't see how we'd be getting that from here. The energy should be negative.
Energy, I'm positioning it on energy, dear. I'll take ellipse. The special case of ellipse will be a circle, right, dear?
Yes, sir. But for that, E would have to be 0.
Yes. But the problem over here being we are in adherence to a follow-up which is counterintuitive to what you are suggesting. Circle is what we had an objection to, right? As it is not a circle. What now? Let us take energy less than 0. What will be
Sure.
E? Less than 1.
Yes, sir.
We get ellipse.
Yes.
Energy greater than 0. What will be E? Greater than 1. So we
Hyperbole.
get hyperbole.
So it will only stay bounded as long as the energy is negative.
Yes, correct. Bounded
Nice.
means energy. System is bounded means energy is negative. Total energy is negative. For any bounded system, total energy will be negative, be it nucleus with electrons, sun with earth, planet with satellite. Total energy is bound to be negative. Now to the term which I was referring to, Vasudev, could you please tell me what did we write eventually? To begin with, we wrote 1 minus E square is equal to L by A. Please do check. When I began the class, we began with the premise that L by R is equal to 1 plus E cos theta. And we added the two terms. What do you think?
So what's A again? There's a lot of variables here.
Okay, fine. For now, you write this down. This energy equation is important. Anyway, check once.
Yes.
Can you further?
Yes, sir.
L by R is equal to 1 plus E cos theta we wrote. Can you recollect?
Yes, sir.
Okay. So L by R is equal to 1 plus E cos theta. We take two angles now. L 1 minus E cos theta is equal to R from here, 1 plus E. We take two angles 0 and 180. So 1 L divided by first one is L divided by 1 plus E. is equal to R, and L divided by 1 minus T is equal to R, right? For two angles,
Yes, sir. Yes.
right? So what do we get from here? What do we get from here? Can you please come up with 1 minus E square? What will be 1 minus E square? Will it be L by A? 1 minus E square, can you please tell me? Just add them, you will get from there.
So
1 by 1 minus E plus 1 plus E is equal to 2R, right, dear?
So wouldn't it be easier to multiply them if you just want to get one
Yeah,
minus E square?
fine. Whichever. 1 minus E square will be what to us? L by A. I want this endorsement. That's it.
So right now I'm getting L squared by R squared. I think if you substitute in A, you would substitute for R, you'll get that. So what's A again?
A will be the semi-lattice rectum, dear, because you have taken the angles as 0 and did you get what the angles were? Which angle
Yes,
I
sir.
was referring to? The first
This
case
is
theta,
0
what
and
was it? And if you take theta equal to 0 over here, it'll go straight and what this way? Either 0
sir.
or 180. So that'll be the semi-major axis and the major axis measurement.
What was the expression we got for A?
A. This A is a new that I have introduced here.
Yes. Sir. So like I need
And
some way to
R-
relate it with R, right?
Yeah, R cos 0 and R cos 180. R cos 0 is 1A, R cos 180 is the other A. In the ellipse, Vasudev, this is the ellipse. So we take this as A, right? A, right? AE,
Yes, sir.
this one, EE, this one minus AE, correct? I'm
Yes.
referring to that one. 0 degree, 180 degree.
Yes.
1 minus zeta square, or yeah, I'll say 1 minus E square is equal to L by A, correct?
Yes, sir.
And what is 1 minus E square from here? Can you tell me? 1 minus E square from here. It'll be minus of 2E H square by G square M square M, right? Check,
Yes, sir.
right?
Yes, sir.
Visible?
Yes, sir, it is.
So, what do we end up getting? Tell me, please.
So what are we solving for?
1 minus E square we are finding there. 1 minus E square. 1 minus E square, we got this from energy equation, correct?
Yes, sir.
So we can write 1 minus E square as L by A, right?
Yes, sir.
And L we have for H square by GM. Remember? L. What was L? What was L? H square by GM over here.
Yes, sir. Kind of getting hard to keep track of all the variables here.
Yeah. H square by GM. That's the reason it's never taken there.
Yes, sir.
H square by GM, right?
Yes, sir.
I just play the value of L, H square by GM, correct?
Yes, sir.
And E, correct?
Yes, sir.
You got energy from here as minus of GMM by 2A. Check. H square cancelled, right?
So your video feed's frozen.
Yeah, now it'll freeze because it's gone 100% over. But we got lucky over with the class as well. Check here. It's fine. Final equation of energy.
So could you repeat the equation again?
Minus of G capital M small m by twice of A.
Yes, sir.
As h square will get cancelled, you'll get energy as minus of 2 G capital M small m by twice A.
Yes.
Which we get very simply when we use a circle. We have got it over here with the actual uses of orbit, the shape being elliptical. Look at here. Point to remember, point to commit to memory. Centricity energy relation according to the orbit and how you prove the others which are into coming. For example, how you prove t square is directly proportional to a cube, not r cube, but a cube. You will get from here. If you further this, you'll be able to prove that t square is equal to a cube. It is not difficult. That I leave for you. I'm already exhausted. Thank you, dear. Thank you for bearing. I really do appreciate. I know what torment I made you go through. Okay, but let me tell you, it was equally taxing on me. Okay,
Yes.
thank you. Thank you.
Yes, I had just one question I was meaning to ask you.
Yes, yes,
What happened?
Vasudev.
So what about the math classes? He said I would be having one last Thursday, but that didn't
That
materialize.
I was to arrange on Thursday, dear. But Thursday was travel for me. All of a sudden, I had to travel to Patna. That's the reason could not get actualized.
Yes.
Okay, the day I'm back, or even if I'm not back, I'll be trying to arrange on Monday. That is tomorrow. If not tomorrow, let me speak to the guy tomorrow. Most probably, I'll be arranging in the evening.
Sure, sir.
Yeah. Most probably tomorrow I'll be arranging. I'm also looking forward for. Let me tell you, I'm also looking forward for chemistry. Okay, so it may get established this week per se.
Yes, sir.
Okay. Okay. Okay, let me thank you.
Thank you, sir.
So